So in this video we'll be covering basic probability. Now we'll include some notes and a worksheet in the description below for you to practice everything you learn in this video. Now probability is a measure of chance or the measure of the likelihood of an event happening. Now at a very basic level we can describe the probability using words and using the scale that you can see on the screen. So typical words are impossible, very unlikely, unlikely, even, likely, very likely and certain. Now, it is very common to be given a list of events for you to either comment on its likelihood using these words or placing them on the scale which starts from impossible to certain. So if we look at this particular scale, this is where you've got zero chance of something happening. So for example, being able to grow wings to fly, if you are a human, that is, not if you're a bird, because obviously that's pretty certain, depending on what type of bird that you are. And certain, for example, is that the Earth will continue to spin, touch wood. Okay, so there are certain things in terms you want to measure. Now, depending on the certain circumstance, I wouldn't think too hard about certain things. So for example, if a question asked you what are the chances of the next person walking through the door being male, try not to think too much about that. So for example, if you're living in a household full of women, or in a room, in a building where there's only women there, then obviously that's going to be a zero chance of a male walking through. However, because obviously it's 50-50, I know that's been politically incorrect, but again, you probably go for an even chance based on the sort of age of the questions that's probably going to be asked. So now in maths, rather than using words, and let's just get the screen up, there we go. So in maths, rather than using words, instead we use decimals as a number between 0 and 1, or fractions as in proper fractions, not top-heavy fractions or improper fractions. And in some cases, we also use percentages as a measure of probability. Now here you can see that we've got a line. Now 0 is always going to be our first extreme value on the left, and 1 is going to be our extreme value on the right. So looking at halfway, that's always going to be a half. Now, the next thing you then need to do is look at how many dashes you've got and then splitting this up into fractions. So for example, here we've got 10 dashes. So this is going to be 1 out of 10, 2 out of 10, 3 out of 10, 4 out of 10, 5 out of 10 is just a half, 6 out of 10, 7 out of 10, 8 out of 10, and 9 out of 10. And again, you could go on to simplify those fractions, but I would usually go for however many slashes there are, just go for the numbers unsimplified. Now, if I was to convert those into decimals, and again, all I need to do is just type in 1 divided by 10, and it'll give me 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 100. Or not 100, 1 rather. So looking at this then, so you can see how we've got a fractional scale and we've also got a decimal scale. Now if you had a scale that was split up into different parts, so here we've got a scale that's split up into 4s, then again I've got half and I've got 1. So this time it's going to be a quarter, an eighth, 2 eighths, 3 eighths, and then this will be the same as 4 eighths, 5 eighths, 6 eighths, 7 eighths, and then obviously then I can convert that into percentages as well. So for example here we've got 0.25, or we can have 25%. Let's just get rid of that line there, like so. So here we've got 50%, then we've got 100%, and we've got 0%. This here is going to be 25%. This is going to be 75%, and then we've got 87.5%, 62.5%, and then we've got 37.5% and 12.5%. And again, how I've got those percentages, so from there, all I've done is just done the numerator divided by the denominator times by 100, and you've got your percentages. Now again, the most popular way of writing probabilities is as decimals or as fractions. So try and avoid using percentages. I'm not going to say that they're never going to be involved in probability questions, but typically at GCSE level, most percentages are always going to be written as a fraction or as a decimal. Now, when calculating probabilities, we can work out the probability of an event by using the following formula. Now, depending on what revision guide, what website, or what your teacher says, or what you've written in your exercise book, etc., you might have this formula worded slightly different, but it generally means the same. So the probability of any event is always the number of ways that event can happen divided by the total number of possible events. Now, before we get started, let me just talk you through some of the notation. Now, the P basically means the probability, and the event is what you want to happen. So that's basically what this notation is. So rather than writing the probability of tomorrow being sunny, I could just write P and then tomorrow being sunny. And then a number of ways it can happen. So let's just go through an example. So for example, if we go through rolling a die and it landing on a 3. Okay, so how many 3s are on a die? So in terms of the probability of getting a 3 is going to be equal to, well, how many 3s are there on a normal die? That's going to be 1. And how many numbers are there in total? 6. And there is the probability of a regular unbiased die landing on a 3. So let's work through some common examples of working with basic probability. So in this first question, it says that the letters which make up the word mathematics are put in a bag. A letter is taken out of the bag. Write down as a fraction the probability of choosing, and then A is A, B is T or M, and C is a vowel. So looking at this particular question, the first thing we notice is that they want us to write the probability as a fraction. So looking at question A, so the probability of selecting an A is, and again, thinking about how many A's have we got in total. So we've got 1 and we've got 2, so that's going to be 2. And then how many letters have we got all together? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So your final answer then is going to be 2 over 11. Now, the one thing you want to do when you're writing things as a fraction is always check to see if you can simplify. So obviously you don't need to worry about if you're writing as a decimal, but because the question is asked as a fraction, always try and think to yourself, can I simplify, yes or no? Now moving on to question B, so let's just pick a different colour. Let's go for pink. So the probability of selecting a T or M. So from this, what I want to do is find out how many T or M's I've got in this particular situation. So here I've got 1, 2, 3, 4, so that's going to be 4 possible outcomes, and that's out of a total of 11 letters, so it's going to be 4 out of 11. And then finally looking at C, which is the probability of a vowel. So looking at this, how many of these letters are vowels? So again, remembering that the vowels are A, E, I, O, U. So one vowel, so I've got 1, 2, 3, 4. So again, it's going to be 4 out of how many letters there are in total, which is 11. And there is my final answer. And again, I can't simplify any of those fractions, so I just leave it as it is. So moving on to the next question, it says that Bradley takes out a ball at random from this bag. Work out as a fraction the probability that the ball is A, blue, B, green, or a red or yellow, and C, green. So looking at this again, we're working with fractions. Now, if a question doesn't specify how they want the probability written, then yes, you can choose whether you choose to write it as a fraction or a decimal or as a percentage. Personally, I would say fraction is probably the easiest and quickest, and probably then decimal, and then probably percentage. Percentage will be the last option that I would generally go for. So with question 2, so what I'm going to do is just write this out. So probability of selecting a blue. So here I've got 1, 2, 3 blues out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be 3 out of 10. And again, just a quick check. Can I simplify 3/10? No. So I'll leave it as it is. So for B, we're looking for the probability that it's red or yellow. And again, there's no harm in writing R or Y, which is absolutely fine. Just depends on how lazy you're feeling. So again, let me just get rid of all these markings. So I'm counting how many red or yellow ones we have got. So we've got 1, 2, 3, 4, 5, 6, 7. So that's going to be 7 out of 10. And again, a quick check, can I simplify this? No, I can't, so I'll leave it as it is. And then C, the probability of getting a green. Well, how many green counters are there? Well, how many green balls should I say? There are 0 out of 11. So I can either leave the fraction as it is, or I can just simply write it as 0. Now with question 3, it says that how many more red balls must be added to the bag so that the chances of Bradley choosing a red is even. Now for this, what we need to do is have a look at what is the actual probability of selecting a red ball. So I'm just get rid of those black marks. So here we've got 2 out of 10. So what we'll do is see how many red counters I need to add so that the probability is going to be a half, because obviously that's going to be an even chance. So remembering that if I add one to the top, then I also need to add one to the bottom. So then the next one, if I add an extra red, that means there's going to be 11 balls in the bag. Add another one, that becomes 4 and 12 in total. Then it's going to be 5 and 13 in total, 6 and 14 in total, 7 and 15 in total, and 8 with 16 in total. So here is the one that we're needing. So the question says how many more red balls do we need? So let me just highlight that. So we need 8 balls in total, 8 red balls I should say. Let's just get rid of that. So 8 red balls. So that means, so therefore we need 6 more red for there to be an even chance of Bradley selecting a red ball. And there we go. So moving on to the next question. So it says Hassan spins this fair spinner. It says find the probability that the spinner lands on, and then we've got our numbers here. So looking at the first one, so let's go for yellow. So working for the probability that we have a 2. So again, I'm going to see how many 2s have I got So I've got 1, 2, 3 2s. And I've got a total of 1, 2, 3, 4, 5, 6, 7, 8 in total. So it's going to be 3 8s. And again, a quick check. Can I simplify that fraction? No, I can't. So there we go. So the next one is the probability of getting a 1. So how many 1s can you see? Well, none out of 8. So I can either leave the fraction as 0 over 8, or I can just write that it's impossible or 0 chance of you getting a 1. Then for C, it's looking for the probability that the number is greater than 4. So again, remembering that greater than 4 is basically a number that's bigger than 4, which does include 4. Now the good thing about this particular question is that there is no 4s on the spinner. So again, I'm looking for numbers that are bigger than 4, so in which I've got 9 and I've got 5, and that's it. So I've got 2 out of 8. Now this one I can simplify, and that simplifies to give me a quarter. Now good question is, would I lose marks if I don't simplify my fractions? Well, it depends on how many marks the question is worth. Now typically, depending on how experienced you are with maths and how old you are and what year group you're in, there is going to be an expectancy that when you do have a fraction that you should always simplify it where possible. So don't always expect the chance. Always just check with yourself. Okay, I've got a fraction. Can I simplify it? If you can, simplify it. If you can't, then leave it as it is. But always ask yourself that one question. Then for D, we're looking for the probability that it's in the red section. So again, how many sections have I got? So let's just get rid of all that previous markings. So here I can count that I've got 3 red sections out of a total of 8. And then part E says that it's got to be 2 and blue, sorry. So how many 2s are in the blue? So I've got 1 here, I've got 1 there, so it's going to be 2 out of 8, which again simplifies to give me 1/4. So moving on to question 5. So question 5 says Elijah rolls a fair die. Find each of the following probabilities. Now in this question doesn't specify, just like the previous one didn't actually, in terms of giving my probabilities as a fraction or as a decimal. And again, it's entirely up to you, but I reiterate, writing it as a fraction is going to be so much easier. So with question 5a, the probability of getting a 6, well, how many 6s are there on a regular die? That's going to be 1. How many numbers are there in total? 6. So there is my final answer. For question B, it says the probability of a 2 or a 3. Well, how many 2s and 3s are there on a die? Well, there's 1 2 and 1 3. So that means there's 2 possible numbers out of 6. And that simplifies to give me 1/3. And then C, a number that's greater than 1. Well, if I think about the numbers on the die, how many numbers are bigger than 1? Well, that's bigger, that's bigger, that's bigger, that's bigger, that's bigger. So the probability of getting greater than 1, sorry, is going to be, oh, I think it's the other way around. No, that's right. No, other way around. Greater than 1 is going to be 5/6. And again, can I simplify that? No, I can't. So that's going to be absolutely fine. Now with question 6, it says that Layla rolls an 8-sided fair die numbered 20 to 27. So work out each of the following. So again, if I just write down the possible numbers, and there are my 8 numbers. So with A, the probability that I get a 26, well, how many 26s are there? 1 out of 8 possible numbers. With B, a multiple of 3. So looking at a multiple of 3 are basically numbers that are in the 3 times table. So how many of these are in the, well, 21's in the 3 times table, 24's in the 3 times table, and 27 is. So that's going to be 3 out of 8. And again, I can't simplify that fraction, so that's where it is. And then finally for C, which one of these are prime numbers? So here, remembering our prime numbers, well, I've got 23, and that is it. So it's just going to be 1 out of 8. Then moving on to question 7. Now question 7, with probability, you tend to find, particularly in a lot of textbook questions, that it is a lot of old textbook questions involve a deck of cards. Now I'm fully aware that children nowadays are highly unlikely to play with a deck of cards, but it's important that you understand what is in a deck of cards. Now if you've not had practice or not ever never played with cards, I strongly recommend that you do. Not only is it going to be educational, which I've just made it sound really boring, but it's also going to be, it's quite fun as well depending on what games you're playing. So let's have a look at this question. So it says that Finley picks a card at random from a normal pack of 52 playing cards, and says write down the probabilities. Now, if you're not too sure about what the suits are, now in a deck of cards you have a total of 52 cards, and from those 52 you have 26 red cards. Oh, I think that's more orange. So 26 are red, and I'm going to struggle with the next one, and 26 are black. Now from the red section you're going to have 13 of those red cards are hearts, and 13 of those red cards, of those 26 red cards I should say, are going to be diamonds. Now from the black cards you've got, again this is going to be, you've got 13 spades, clubs I should say, and you've got 13 spades. Now in each of those 13 cards you can have an ace, you can have a king, you can have a queen, you can have a jack, and then you're going to have the following numbers. So you can have 10, 9, 8, 7, 6, 5, 4, 3, 2, and they make up your 13. So going back to this particular question, it's saying what's the probability of getting a diamond? Well, the probability of getting a diamond is going to be 13 out of 52, which simplifies to give me 1/4. For B, what's the probability of selecting a queen? Well, if each suit has got a queen, so that's going to be 4 out of 52, which equals 1/13 when I simplify it. And then finally, for C, the probability of getting a red jack. Well, how many red jacks have I got? Well, I'm going to have one red heart and one jack diamond. Sorry, let's repeat that. I'm going to have one jack of hearts and one jack of diamonds, so I've got 2 in total out of 52, which gives me a total of 1/26 as my final answer. And then moving on to the last question. So here it says that Ava has 8 cards numbered 1 to 8. She shuffles the cards and places them face down. Ava turns over a card at random, and so question A says, what is the probability that the first card she turns is going to be a 7? Well, looking at the number of cards, she's only got the probability of getting a 7 is going to be 1 out of 8. Then for B, it says, if the first card is 5, what is the next card? Well, what is the probability that the next card she'll turn over is going to be a 6? Well, if I just write down a 5 in one of the cards, then how many cards have I got left? Well, how many 6s are there? Which is going to be, so the probability of getting a 6 is therefore going to be 1. And out of how many cards I've got left, well, that's going to be 1, 2, 3, 4, 5, 6, 7. So it's going to be 1 out of 7. And then for C, it says that the first card is 3. What's the probability that the next card she turns over is going to be higher? So it's higher than 3. So if I just get rid of that 5. So she's turned over a 3. And so how many numbers are higher than a 3? So it's going to be 1, 2, 3, 4, 5. And how many cards are going to be left? Well, that's going to be 7 again. So it's going to be 5/7. And there we go. Now, we'll put some practice questions in the description below for you to practice some general probability. And I'll also include the answers for you to check and mark your own work.